We have made several enhancements to Point Cloud capability of ERDAS IMAGINE for the 2016 release. The enhancements can be broadly categorized into two groups. The first one is enhancement dealing with interactive visualization, and the other is enhancements done to the Point Cloud operators. In this video, we'll focus on the visualization enhancements. The first one worth mentioning is the addition of support for LAS version 1.4. SPRS has introduced version 1.4 a while ago, and this version has a number of upgrades compared to version 1.3. To name a few, LAS 1.4 supports 256 classes, it supports up to 15 returns, new standard classes are added, the reserved classes are expanded, and user-definable classes are introduced. Customers have been asking that we support LAS 1.4, and we have done that in the 2016 release. So let's load the 1.4 data and bring up its Point Cloud info. Okay, as you can see, it is properly identified as version 1.4. Other than that, it's pretty much what you were able to do with previous version. You should be able to do with version 1.4. Starting the 3D viewer, playing with the view perspective. Let's see, selecting points for editing them, or selecting a profile view. Anything that you have been able to do with previous versions of LAS data, you should be able to do with 1.4. Alright, the next enhancement we'll look at is styling persistence. If you load a shapefile in the viewer and change its display style, such as its color or line weight and so on, you can then save the style, and the style will be reused whenever you load the shapefile. You can now do this with point clouds. So let's see how this works. We have a point cloud that's loaded in the viewer. I'll go to the point cloud tab and change its point size and change its color, and then let me clear the viewer. When I do that, it will ask me if I want to save the point cloud symbology. Let's do that, and the view is cleared, and let's reload the point cloud, and you see that the style has been persisted, and whenever you reload the point cloud, it will be loaded using the saved style. This applies not only to the 2D viewer, but the profile views and the 3D viewer. The next item that we'll look at is Z scaling or Z exaggeration in the 3D viewer. We already have this scaling in the profile views, and we have extended this to include 3D viewer. Let me change the point size back to 1 and start the 3D viewer and change its perspective so that we can easily see the Z-scaling effect. The Z-scaling for the 3D view is also controlled by the same Z-scale setting in the display group. I will increase this now by some factors, changing by 1.5 by 2. As you see, as I increase the Z-scaling factor, you see the separation in Z between ground and the other features. This makes it easier to distinguish features and to do the interactive analysis. The coordinates themselves will not be changed. The change is just in the display. The last but not the least enhancement we did for Point Cloud Visualization is the ability to measure in 3D viewer. Prior to this release, the 3D Point Cloud Viewer was just for viewing purposes only. In 2016, we have added the ability to measure points, the coordinates of points, measure distances, and measure height from a surface. So let me demonstrate how to measure a point. You select that, and that brings up the cell array at the bottom of the view, and you go to the point that you want to measure, you click on it, and that will record the coordinate of that point in the cell array. I can do the top of the other utility pole there. So I have measured the XYZ coordinates of those 2 points. Let me do the line also. I will measure the distance between the 2 transmission poles. Click on the first, you see that line, and double click on the last point, and that will also be recorded. You can basically write your comments, and you can save this to a text file for reporting purposes. 3D measure. Alright, so this concludes the enhancements we did in this release for Point Cloud Visualization.